Algebra 2, 5-4, analyzing graphs of polynomial functions. Yikes, that's a lot to write. 5-4, analyzing graphs of polynomial functions. Okay, example. So today, it's a little short, we're going to do 2 examples. We're just going to graph 2 polynomials. This one is negative x to the 4th power plus x cubed plus 3x squared plus 2x. That is our polynomial that we are going to graph. Now, we don't know much about this polynomial here, but we can graph this. And one way to graph this is to just plug in x values and find out what our y value would be if I plug in a certain x value. Now, if you remember, I don't know if we talked about, pretty sure we talked about this in Algebra 1. But I want to plug in some values for x. And so I'm just going to choose several here. Let's say -2, -1, 0, 1, 2, and 3. We're just going to plug those values in for x. And we could plug them in here, or there's another way I'm going to show you how to plug them in that's a little bit faster. But before we do, let's just plug in 0. So if I plug in 0 for x, I get 0 for y. Okay, that one's easy. I know I got 0, 0. Okay. Now, let's see, what's another easy one here? Let's go +1. So, +1 to the 4th power is going to get me 1, so that's -1, plus 1 cubed is 1, plus 1 squared is 1, times 3 is 3, plus 2 times 1, which is 2. So I got -1 plus 1, that's 0. 3 plus 2 is 5. Okay. Now, I'm going to show you a way to use something that we learned recently to use as at our advantage here. So let's say -1. I want to plug -1 in here, but I don't really want to do all that work. So I'm going to put -1 in this box. Remember this box from just a few days ago? My leading coefficient here is -1. My leading one is here is 1, 3, 2, and then I don't have a constant here, so I need to put 0 here at the end. Bring that -1 down. -1 times -1 is +1. 1 plus 1 is 2. 2 times -1 is -2. 3 plus -2 is 1. 1 times -1 is -1. Plus 2 is 1. -1 times -1. -1 times +1 is -1, plus 0 is -1. So I got -1 when I plugged -1 in. -1, -1. Mr. V, what? Can I do that? Yes, you can. You're welcome. Let's plug in 3. So I'm going to, the same stuff on top. -1, 1, 3, 2, 0. 3 times -1 is -3, and 1 is -2 times +3 is -6, -3, -9, -7 times 3 is -21. So if I plug in +3 in here, I'm going to end up with -21. All right. Now, I'm going to give you some of these other answers here. If I was going to plug in -2, then I end up with -16. If I plug in +2, then I end up with 8. Okay, now let's draw our graph. Let's see. Let's make some 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15, 16. Okay. Now, let's plug it, let's do these points here. Negative 2, negative 16. So negative 2, negative 16 is going to be way down here. That's fine. Negative 1, it's right there. 0, 0, I already got. 1, 5. 1, 1, 2, 3, 4, 5. Right there. 2, 8. 2, 5, 6, 7, 8. There we go. And then 3, negative 21. 3 way down here, negative 21 is going to be way down here. So now I'm going to connect these dots. So I'm connecting them from left to right. Go up, like this, up, down. There's my arrows, there's my arrows. Okay, now we need to look at this graph, and we're going to analyze this graph. We're going to talk about the important parts of the graph. So you might remember from Algebra 1 that this part here is the maximum. And there is no minimum because these arrows just go on forever down. Now also this point here and this point here where the graph crosses the x-axis, those are called zeros. And then we can also talk about when x goes to negative infinity, what does f of x do? We can talk about when x goes to positive infinity, what does f of x do? And we can write down the zeros. We'll write them up here. Okay, so let's talk about when x goes to negative infinity. So the farther we plug in, the more negative numbers we plug in, the farther down this arrow, this graph is going to go. So as x goes to negative infinity, so does f of x. F of x also goes to negative infinity. When x goes to positive infinity, if we plug in more points along this x-axis, we're going to get farther and farther negative with the f of x. So they both go to negative infinity. Now, is this an even or odd degree? Since both arrows are going the same direction as far as f of x goes, then we have an even degree polynomial. Also, we can look right here. The leading, the degree of this polynomial is 4, so it's even, and it's 4. All right, now let's talk about these zeros. So the zero, we have two zeros. One of them is 0, 0. And the other one is something 0, right? The y value is going to be 0, but we don't really know what the x value is. The x value, and I haven't drawn this perfectly, but we can look right here, where the y value, here's the x value, 2 and 3 right here, and then the y value changes from positive to negative. Since the y value changed from positive to negative, we know that that graph has crossed the x-axis. It went from positive to negative. So between 2 and 3, 0. So we have a 0 that crosses the x-axis between 2 and 3. I haven't drawn it here perfectly, but we can see here by our t-table. Between 2 and 3, the graph crosses the x-axis, and then, of course, the y value is going to be 0 because it's always 0 at a 0. There you go. All right, let's do one more. We'll just do this one together. Locate zeros in graph. here's our example. F of x equals x cubed minus 4x squared plus 3x plus 1. All right. So we have a t-table. We'll put it over here like we did last time. So if you want to pause and get to work on this the same way that we did on this first one, go ahead. I'm just going to keep going. So I need to plug in some values for x, and I'm going to use the same ones I did last time. -2, -1, 0, 1, 2, 3, and it looks like this time I might even need to do number 4, see what that does. So if I plug in 0 for x, I get 1. If I plug in 1, I get 1 minus 4, which is -3, plus 3, which is 0, plus 1 is 1. Now I can go through and plug in these other numbers here too, but I'm going to just give you those answers so that we don't have to sit here for a long time. 0, when I plug in -1, I get -7. When I plug in -2, I get -29. And you can do that here with this synthetic division, or you can just plug and chug. If I plug in 2 for x, then I get -1. And when I plug in 3, I get +1, and when I plug in 4, I get 13. All right, so let's plot these points. 1, 2, 3, 4. Okay, so -2, -29 is going to be way down here. -1, -7 is going to be right here. 0, 1, 0, 1 is right there. 1, +1 is right here. 2, -1, right there. 3, +1. And then 4, 13 is going to be way up here. All right, so let's draw our curve from left to right. Comes up, comes back down, goes back up, and up like that. And we knew it was going to look like that because it is the degree of 3, and so it's going to start low and go high, or it'll start high and go low. And if it's positive, it's going to start low and go high, if we're reading the graph from left to right. So here we have a relative max, and here we have a relative min. Relative meaning it's just in this area. We get more negative, we get more positive here, but since it does this little bump, we can call that a relative max and this a relative min. Now, we have the graph, the polynomial crosses the x-axis 1, 2, 3 times. So let's find these zeros, excuse me, zeros. Let's do that. So 1, 0 is here, and then and here and here. So let's look at our t-table and see if we can see, like maybe we didn't draw a graph perfectly. This one I did draw better than the last one, but let's look at our graph, and we can, at our t-table. So when we look from left to right on our x-axis, negative to positive, left to right, we can see right here it goes from negative to positive. So we know there's a 0 here. And we can see from positive to -1, so we know there's a 0 here. And from -1 to +1, there's another 0 there. So those are where those zeros are happening. And so pay attention, here's where the x value at that spot, x value at that spot. So we should probably be kind of circling this whole thing like this. So here are the zeros. They are between -1 and 0. So we're looking at the x values here to tell us where that is occurring. We look at the y values to see that it is occurring. We look at the x values to see where it is occurring. All right, so between 0 and -1, between 1 and 2, and between 2 and 3. Those are the x values where the graph crosses the x-axis. All right, these relative max and min, these are also called extrema, and they're also called turning points. Okay, you might see either of those in the book, and we are almost done here. We did not do this whole as x goes to positive infinity or negative infinity, f of x goes to negative infinity, and when x goes to positive infinity, this direction, y goes up, f of x goes to positive infinity. Is this even or odd? If the arrows are going in opposite directions on the y-axis, then we know this is odd. Also, we can see it here, x to the third power, it's going to be odd. And that is all that we are going to do for 5-4. So just follow these examples on your homework and you should be all set. Good luck.